Our entire solar system could vanish inside a single black hole. Not just Earth, not just the Sun. Every planet, every asteroid, everything you have ever known, gone without a ripple. And compared to the largest black hole we have ever found, even that barely registers. By the end of this video, you'll understand why astronomers still aren't sure how something this big is even allowed to exist. Start with Earth, the whole world you know, every city, every ocean, every person alive. Now put it next to the Sun. You could fit about 1.3 million Earths inside the Sun. Light can circle the Earth 7 times in a single second, but to cross the width of the Sun, it takes nearly 5 full seconds. And yet, in the universe, the Sun isn't even considered big. It's an average star. It only feels enormous because your brain evolved on a small rock orbiting it. But stars die. And when the big ones die, they leave behind something that makes even the Sun look insignificant. Take a star several times heavier than the Sun and let it reach the end of its life. The core collapses. Gravity wins. A black hole is born. A typical one of these holes may be 10 or 20 suns worth of mass. That sounds enormous. But here's the weird part. All of that can be crushed into a region just a few dozen kilometers across. A black hole with 10 times the Sun's mass could be smaller than a city, yet its gravity is strong enough to trap light itself. So you've climbed from Earth to the Sun, to an object backing multiple suns. And yet at the center of our galaxy sits something that makes all of it look microscopic. At the heart of the Milky Way lies Sagittarius A star, our galaxy's supermassive black hole. Its mass equals roughly 4 million suns. Not 4 million Earths, 4 million suns. Its event horizon is about 24 million kilometers wide. Our entire Sun would fit inside it 17 times over. Whole stars orbit it like moths around a flame. This is the dark, silent anchor at the very center of a galaxy of 100 billion stars. A monster, a cosmic heavyweight. And yet, it's one of the smallest of its kind. Because our galaxy, it turns out, got a quiet one. Here's what almost no one realizes. Sagittarius A star, for a supermassive black hole, is small. Travel to other galaxies, and you find these giants routinely running into the hundreds of millions of suns. Some pass a billion. Take Messier 87, a galaxy 55 million light-years away. In April 2019, after linking radio telescopes from across the entire planet into a single observatory the size of the Earth, humanity did something that had never been done before. We measured a black hole this size for the first time. The first black hole humanity ever managed to capture. And its mass is around 6.5 billion suns. That's more than 1,000 Sagittarius A stars. Its event horizon is so wide that our entire solar system, all the way out to Neptune, would fit inside it with room to spare. And this, a black hole this far away, 1 billion times the Sun, is still only the warm-up. Look at this dot. That is Messier 87, 6.5 billion suns. The biggest thing we've seen so far. Now watch this. There is an object so extreme that we don't measure it in millions of suns, not hundreds of millions, not even a single billion, tens of billions. It has a name, Ton 618. Its mass is around 40 billion suns, and some older estimates put it as high as 66 billion. We're not even certain how heavy it is, because it's so far away, we can only weigh it indirectly. Either way, that's around 6 times the giant we just photographed, and roughly 10,000 times the monster at the center of our own galaxy. Its event horizon is wider than our entire solar system. Drop it where the sun is, and it would swallow every planet, Neptune's orbit, the Kuiper belt, almost everything you think of as our cosmic neighborhood, gone many times over. But here's what truly breaks the mind. Ton 618 isn't dark. It is one of the brightest single objects in the entire universe. As it devours matter, the gas spiraling into it is torn apart and heated to millions of degrees, and it screams with light. This one shines with the power of roughly 140 trillion suns, outshining our entire galaxy thousands of times over. We see it because it is monstrous, but we also see it because it is ancient. Its light has traveled for billions of years to reach us from the early universe, which forces an even bigger question. How does a monster like this even get born? Black holes grow by eating gas, dust, stars, and sometimes other black holes. Over billions of years, that feeding can build a supermassive giant. But Ton 618 pushes the idea past the breaking point, and the reason is time. When we look at Ton 618, we're seeing it as it was in the early universe, only a few billion years after the Big Bang. Imagine trying to grow a fully finished skyscraper overnight. That's the problem astronomers are staring at. It grew to tens of billions of suns shockingly fast, far faster than it should have been able to, because there's a hard limit on the throttle. The bigger a black hole gets, the brighter and hotter its feeding becomes, until the radiation pressure blasts its own food supply away. Past a certain rate, it literally starves itself. So how did it get so big, so early? The leading idea is that giants like this didn't start small. Instead of beginning as a single collapsed star, a seed of a few dozen suns, a vast cloud of primordial gas may have collapsed directly into a black hole, already tens of thousands, even a million times the mass of the sun. A heavy seed, a head start of a million suns, born ready to feed. And in 2023, telescopes found a candidate, a baby black hole in the infant universe that looks exactly like one of these direct collapse giants. But it's still one of astronomy's open mysteries. Some models suggest black holes may struggle to grow beyond a few tens of billions of solar masses. Ton 618 sits right around that territory, which means either our math is incomplete, or something we don't yet understand is feeding these giants past the point that should be possible. Ton 618 is among the largest black holes we've ever found, but the universe is unimaginably vast, and we've explored only the tiniest fraction of it. There are already other candidates that may be even larger, and most of the giants out there are too dark, too quiet, and too far to ever show up in our telescopes. For every monster we can see, there may be countless more hiding in the dark. So could something far bigger be waiting out there? 100 billion suns? 1 trillion? Or are these giants already brushing against nature's hard limit? So tell me in the comments, what shook you more? That Ton 618 weighs tens of billions of suns, or that it may have grown that big before the universe was even old? If your sense of scale just shattered, subscribe. I explore one cosmic mystery like this every week, and next time we're asking something even stranger. If nothing can escape a black hole, then why are they slowly dying? See you there.